So now we are adding or subtracting. I have a fraction being added to another fraction. First thing that you always have to look for is you need to look for common denominators. If it has a common denominator, then you can go on to step 2. I see a 4x here and a 4x here. They have a common denominator. Since they share the denominator, that means the denominator that we are going to be left with is that same denominator. So the denominators do not change. If they were originally both 4x's, I'm still talking in terms of 4x. Now, the numerator, you are just going to add across. So denominators stay the same. And the numerator, you add across. So I have the 7, and now I'm going to add, and I'm adding the 3. So now we were just going to simplify the numerator. It said 7 plus 3, so my numerator is actually a 10. There's nothing to do in the denominator. It's a 4x. Now I have to look at this, and I have to see, is there a way at all to simplify my fraction? And how we simplify fractions is, remember, we need them broken up into their prime factorizations. So 10 is a 2 and a 5. 4x is 2 times x. If I am able to make any 1s, then it simplifies. I can see that these 2's right here are a 1, so they cancel out, and nothing else does, so I am left with 5 all over 2 times x is a 2x. Now we are used to finding our undefines. The only time that you need to find the undefines now, because we have progressed and now we know, it's only if they cancel out. I did not cancel out any variables, so I don't have any undefines that I have to mention. You are right that 4x is in the denominator. 4x does matter, and this is one of the values that I could, if I wanted to, mention. He is not required because he did not actually cancel out. So this is my final answer, and I'm currently done. So our next problem, we're adding or subtracting. I have a fraction being subtracted from another fraction. I have our steps listed here again. The very first thing we need to do is we need to see if we have a common denominator. So looking at my denominators, I have a x plus 6 and an x plus 6, which means the denominator in my new fraction is going to remain as the x plus 6 that we see that they both have in common. Now the denominator is going to stay the same. That's what we did. And now you need to not add across, because this is a subtraction problem. We're going to actually subtract across. So I have a 2x. Here's my 2x. And now I'm supposed to subtract this. So I'm subtracting my 5. So I have a 2x minus 5 in the numerator. And there is no way to rewrite that. So it is 2x minus 5. I have an x plus 6 in the denominator. There's no way to combine like terms in that. Simplifying. I need to see if there's a GCF in the numerator. There is not. There is not a GCF in the denominator. Nothing in the numerator matches anything in the denominator, so there is nothing to simplify. Now we have to look at undefined. You are right that you would test this factor that is in the denominator. And you are correct that this is an answer you could write. But since he did not cancel out from our answer, then we do not have to mention him. So this is our final answer, and we are done. Our next problem, we are adding or subtracting. I have a fraction minus a fraction. I know I need a fraction over here. So looking at step 1, do we have a common denominator? This was a 12x and this was a 12x, so they share the same denominator, which means my answer's denominator is also going to be 12x. So the denominator stays the same. The numerator, you're either going to add or subtract across based on what kind of problem you have. So we have an 8, and now I'm supposed to minus the 5. So here's me minus my 5. 8 minus 5 is a 3, so my numerator is a 3. My denominator, there are no like terms, so he is 12x. I now need to simplify. I can see that I can actually break these up into prime factorization, so I'm going to break 12 up into its prime factorization. I can see that this 3 will 1 out with this 3. So my 3's end up canceling out, so I do have a simplified answer. So I have 1 all over 2 times 2 is 4, so that is a 4x. I'm supposed to look for undefines. And you are right that 12x would be the value that you would check as an undefined. But since he did not cancel out in here, we don't have to mention him. You could. It wouldn't be wrong, but we don't have to. So this is my final answer, and I am done. Our next problem, we are adding and subtracting. I have a fraction being added to another fraction, so I know I'm going to get a fraction in my answer. First thing I need to do is I need to see, do I have common denominators? This was a 3x squared. This also is a 3x squared. They are common, which means that my denominator is just going to stay the same. So this is also a 3x squared. I'm supposed to add or subtract the numerator straight across. So this was a 2, and now I'm supposed to be adding the 1, so 2 plus 1 is in my numerator. 2 plus 1 simplifies to 3. The denominator is still 3x squared. So now I need to try and simplify. If I prime factorize all this, I have 3 times x. I can see that these 3's would 1 each other out. Nothing else would cancel out. So I'm left with 1 all over x squared. Looking for undefined. You are right that I would have checked this as an undefined value. And x equals 0. I would write x equals 0 here. I could write x equals 0 here. But since it didn't cancel out, none of my variables canceled out, I don't have to. You could, not wrong, but not have to. So this is my final answer, and I am done. So now we are adding or subtracting. I have a fraction minus a fraction, so I know my final answer is going to be some kind of fraction. I need to first check to see if I have a common denominator. This denominator said x minus 2. This denominator also said x minus 2. The denominators are supposed to stay the same. So since they're both x minus 2's, my denominator then is going to be an x minus a 2. The directions tell me that I need to either add or subtract across. So I had a 4x, and now I'm subtracting another x. So if I had 4x and I subtracted an x, I have a 3x. My denominator is x minus 2. Can I simplify? There are no GCF or prime factorizations. There are no GCF or prime factorizations, so he cannot simplify at all. If I was doing undefined, I would check x minus 2. And you are correct that x equals 2 is a value that I would write as an undefined value. But since it did not cancel out at all, I don't have to. So this is going to be my final answer, and I'm done. Next problem, we're adding or subtracting a fraction. So I have one fraction being added to another fraction, which means I'm going to have a fraction answer. I'm first supposed to check to see if they have a common denominator. This has a denominator of x squared plus 1. This also has a denominator of x squared plus 1. They are the same, so the denominators are just going to stay the same. So my denominator is x squared plus 1. I'm supposed to either add or subtract across according to the type of problem we have. So I have 2x squared. And then it says I'm adding 2. So here's me adding 2. There are no like terms to combine. There are no like terms to combine. So now I'm just going to see if there's any way that I can simplify it. This numerator does have a GCF of a 2. So I'm going to factor out the 2. And when I do that, I'm left with x squared plus 1. The denominator does not have a GCF. It is x squared plus 1. I can see that the x squared plus 1 factors in both the numerator and the denominator. So they one each other out. They cancel each other out. So my final answer is a 2. Now when I come over here to undefined, we would have checked the x squared plus 1 because he was what in the denominator. So if I'm solving for x, I end up getting x squared to equal a negative 1, which means I'm going to be taking the square root, and the square root of a negative 1 is I. Now, when we are looking at this, we are only looking for real numbers. I is not real. I is imaginary. Since I is imaginary, we are not going to list it. We only want you to list the real numbers that make it undefined. So we're not going to list this. Your answer is just 2, and you are done.